Hello and welcome to another Ramble with me. We are rambling about IEB May 2025 paper 1. Question 10. I'm kind of nervous about this because I'm not so comfortable with log graphs. But the key thing to remember about log graphs is that they're just the inverse of exponential graphs. So, yeah. The sketch below shows the graphs of f of x is equal to log base 2x and g of x, which is log base 2 x minus 5. So g of x is essentially this graph moved 5 units to the right, right? So that minus 5 that is acting directly on the x tells us that, if you look at the graph, all the points have just shifted 5 units to the right. Okay. Give the equations of the asymptotes of f and g. So we know that a normal log graph, its asymptote is the y-axis, the same way that its exponential counterpart, the asymptote would be the x-axis if the graph hasn't moved up or down, hasn't moved left, or even if it has moved left or right. So yeah, this one, the asymptote will be the y-axis. So asymptote of f is y-axis, in other words x equal to 0, right? And then next up, the asymptote of g will just be 5 units to the right of that, so that will be the line x is equal to 5. And again, if you think about its exponential counterpart, this would be the exponential would be 1 where the exponential graph has moved up by 5 units. How do I know that? So let's just say we have y is equal to log base 2 x minus 5. To find the inverse, I'll switch these around, and then I need to make y the subject of the formula. So we know that this is the same as 2 to the x is equal to y minus 5, which is the same as y is equal to 2 to the x plus 5. So you see that this would be a y is equal to 2 to the x that has moved up 5 units, and so therefore the asymptote would be y is equal to 5. So then it makes sense that the asymptote of the inverse will be the reflection of this guy in the y is equal to x line. So it would be the x is equal to 5 line. Hope that makes sense. So that's another way to think about it. Right. For which values of x will f prime x times g of x be smaller than or equal to 0? So let's see. F prime x, if we look at this curve, it's always increasing, right? There's no point where this is going to be a decreasing function. So f prime x is always greater than 0 on its domain, right, for all the valid x values. So the only way that this product can be smaller than or equal to 0, i.e. negative, is if g of x is negative. So we're looking for g of x smaller than or equal to 0, right? And so which part of the curve is that? That would be this part of the curve, right? This is where the function is outputting negative values. Ooh, burp. Right? And so we need to find out the coordinates of this guy here, the x-intercept. So we need to find out, so therefore solve where is g of x equal to 0. So where is log base 2 x minus 5 equal to 0? So if we rewrite that in exponential form, we have that. And so that is 1 is equal to x minus 5, and therefore x is equal to 6, right? So the coordinates of this guy are 6 and 0. So what we then know is that for any value of x that is smaller than 6, and also we need to remember the asymptote here that we discovered in the previous question. So I'll just put it here. The asymptote being x is equal to 5, right? So if we, for any x that is bigger than 5 and smaller than 6, we have f prime x times g of x will be smaller than or equal to 0. And we don't include the 5 because this curve is not defined there, right? It's an asymptote. We include the 6 because when x is equal to 6, the gradient of this curve is positive. As we noted, it's positive for any x value. The value of g is 0. So if you times the two together, you're going to get something equal to 0. And in this inequality, we're looking for places where the product is smaller than 0 or equal to 0. So the 6 also qualifies. Right. Next up, we have AB is a vertical line segment with endpoints on F and G. For which values of x will AB be equal to 1 unit? So what we know is because it's a vertical line segment, so suppose the x-coordinate of A is P, the x-coordinate of B will also be P, right? And we know that the y-coordinate of A will be log base 2 P, and the y-coordinate of B will be log base 2 P minus 5. So we are looking for places where this vertical distance is 1 unit. In other words, the difference between these two is 1. So we need this difference to be equal to 1. So this is where we need to make use of our log laws. So we know that if they have the same base and we have a difference, then we can combine it into a quotient like that, right? So then again we rewrite this in exponential form. 2 to the power of 1 is equal to P over P minus 5. So we have 2 is equal to P over P minus 5. So I mean, at this point we know that P can't be equal to 5, because then this would be a 0 denominator. In fact, we knew that here already, but anyway, we knew it here already. Right? Because when you're dealing with logs, this number has to be bigger than 0. Right. So to solve this, we can times both sides by P minus 5. Right. So we have 2P minus 10 is equal to P. 2P minus P is equal to 10. And so P is equal to 10. So that means that we have this distance being 1 unit in exactly one place, and that is where the x-coordinate is equal to 10. I've now used P as my unknown. We were meant to be solving for X, but potato. That's my story, and I'm sticking with it. Let's see what the memo has to say. So the two asymptotes are x is equal to 0, x is equal to 5. The solution to this inequality is x greater than 5, smaller than or equal to 6. And then finally, we have x is equal to 10 as our solution for the last problem. Right, thank you for joining the chat, and let us convene another time.